Hello, everybody. We are here with Michael Preusker, Innovation Manager, PSI Transcom, which is partner of the Sustainable Bus Tour 2021. Good morning, Michael.
Good morning.
May you provide us a picture of your company?
Thank you very much for giving me the opportunity to introduce our company. PSI Transcom has 40 years of experience in developing and integrating of software systems for public transport, such as depot management, train management, and automatic vehicle management systems for trains, trams, and buses. These solutions are based on the telematics platform called PSI Traffic, which was developed with event-driven and object-oriented technologies and are constantly being adapted to changing market needs. Our solution improved passenger satisfaction thanks to higher service quality, as well as fast, comfortable, and punctual collections. Customers all over Germany and Europe rely on our solutions, which improve the availability of their vehicles and their personnel.
PSI has been chosen as a supplier of depot and charging management system for Hamburger Hochbahn or BVG Berlin, which are the companies with the largest number of buses in Germany. Why did they decide for your PSI e-bus solution?
Well, as a leading supplier of depot management systems, PSI Transcom was one of the first companies to integrate zero-emission fleets. Our PSI e-bus integrates all types of drives, such as diesel, natural gas, battery electric, and even hydrogen within one system. Thereby helps transport companies with the transition process. PSI Energy, one of the divisions of the PSI Group, is a leading supplier of systems for monitoring, control, and optimization of energy consumption, local supply, and distribution. That's why we can offer sophisticated depot, charging, and energy management systems from a single source. And that saves time. For example, in Berlin, we were able to put the charging management into operation in just 7 weeks. By combining the depot management and the charging management, the system includes the know-how for both public transport processes and energy supplies. It takes into account important parameters that are relevant for efficient controlling, charging, and dispatching of vehicles, both at the depot and along the route. Its modular architecture and open interfaces make it scalable and future-proof.
As e-bus adoption ramp up, interoperability is becoming a crucial topic, both on the side of charging process and on the side of depot management.
The connections between charging planning, dispatching, and block planning are complex and, above all, dynamic. Both static data and real-time data have to be exchanged between the various systems. PSI is a pioneer in standardization of e-mobility in public transport. The data exchange between the charging stations and the charging management system is based on an open and certified interface, the OCPP, Open Charge Point Protocol. In order to support the manufacturers of charging stations with a public transport specific implementation of the standard, we offer the testing and verification of the interface with our PSI e-bus system. Obtaining the so-called PSI Ready certificate for their interfaces enables manufacturers to connect their charging stations quickly and safely to our PSI smart charging system. This ensures a time and cost-efficient integration within specific projects. The specification of the interface between charging management and depot management, shortly available as VDV 2463 standard, was largely determined by PSI Energy and PSI Transcom. Furthermore, PSI is significantly involved in the development of the VDV 261 standard. This involves connecting the e-buses to a dispositive backend, for instance, to a depot management system. This can be used, for example, to control the preconditioning of the vehicle. Both interfaces use the charging infrastructure for data transmission. This means that data is only transmitted when the vehicle is connected to the charging station. In the future, it will be necessary to transfer specific data from electric vehicles to the background systems even without contact with a charging station. With the VDV 238 working group, the work is currently underway on a standard for the real-time transmission of vehicle data over the air.
Technology is evolving concerning buses, but it must get along with an evolution of depot management. And in this sector, artificial intelligence is becoming an important actor.
Yes, exactly. For PSI, artificial intelligence has always been an integral part of our DMS since the first DMS project in 1998. Even when all the buses were powered by diesel engines, we were already using artificial intelligence for refuel optimization. Of course, the complexity of the optimization has increased even more since 2018 when the electric buses came out. Luckily, with PSI FLS, which means fuzzy logic and neural systems, we have an AI specialist inside the PSI group. Their AI-based coalition module has been an essential part of our DMS since 2010. The coalition core is an universal optimization module that is widely used in various industries. In accordance with the specific energy properties, we perform a continuous dynamic vehicle disposition based on an energy forecast for each individual vehicle and many other criteria. For that purpose, we supply the AI module with all relevant data, such as state of charge, vehicle attributes, route characteristics, and even weather conditions. All in all, more than 80 criteria are taken into consideration when optimizing the disposition. Just an example, every minute the DMS gets a new data set from the charging management systems via VDV463 interface, and the optimization algorithm is matching all of the actual data with the current vehicle planning. In case of conflicts, the coalition module calculates a new vehicle deployment plan within seconds. The eDMS with the AI-based optimization is already up and running in Hamburg, shortly also in Berlin, Luxembourg, Paris, together with our charging management system PSI Smart Charging. In Munich and Mannheim, we will introduce our eDMS in connection with charging management systems from other suppliers. Another use case for AI is the so-called multi-criteria charging. This means that not only the energy supply and distribution requirements are important for the charge management, but also the optimization of the battery lifespan and the compliance with warranty conditions of the vehicle manufacturer. That's a use case we are currently working on. We are also planning a comprehensive research project with PSI Energy and other partners, for instance, Hamburger Hochbahn, for which we have already applied for funding.
The use of green energy is a must to reach a real reduction in carbon emissions. And as the electric fleets grow, several depots must be managed together. May you outline future challenges and a view on the future of energy management within bus depots?
Electric bus fleet operators will become operators of a distributed electrical infrastructure, which needs to be monitored and controlled. In the near future, this infrastructure will not only include the charging points, the transformers, and the sub-distribution of the local power, but also energy storage, for instance, second life batteries, and photovoltaic power plants, and other local power producers and consumers. The goal is, therefore, to monitor the entire electrical infrastructure in the depot grids and to optimize its use. Employers in this field require a high degree of specialization, and the work needs to be done with the greatest efficiency. It therefore makes sense to centralize this task and to use tested and proved energy distribution management systems as a basis for charging management system. It will be profitable for bus fleet operators for fluctuations in the public power grid to be compensated by a grid-friendly charging infrastructure. The PSI Smart Charging System therefore offers the possibility of limiting the grid connection power and thus preventing peak loads through peak shaving by distributing charging processes over time. Bus fleet operators thus integrate them into the smart grid, benefit from it financially, and last but not least, support the overarching goal of CO2 reduction.
Thank you for your time, Mikhail.